I know we always head down when talking security and we go in the boardroom, and seeing Scott Kelly before experience alone in space, sometimes we feel a bit like that when in the boardroom as security practitioners. But when I see like everyone in the room here trying to do the right thing and being on the good side, it's actually very reassuring for me. And sometimes we don't give ourselves enough credit as security practitioners. So I want to give a round of applause for us fighting the good fight. So thank you for being that. So for the past 25 years, one thing that's been resonating with me, there was two principles that resonated with me a lot. The first one was security is a catalyst to the business. The business is like driving us towards new heights with AI, but if security is more like I call the doctor no, it will fail because the business will go around it and take bigger risk that actually it needs. So security is just a how, and often I work with like a lot of business leaders that come to me and say, hey, Julian, can you approve that? Can you say that yes to me? Instead of telling them, I don't say yes or no, I tell you how. This is one thing that is very important when you deal with the business. The second principles that I feel has changed in the recent couple of weeks or even months is there was a saying that I really like to say is that we say security was a race without a finish lane. Now, with AI, it's a sprint without a speed limit. And why I say that? There's several reasons around that. So first, the tech stack is changing. We're dealing with data center transformation towards AI factories. Data center, it's like more like a handwritten code on like a system-based CPU, and AI factories are AI written code on system-accelerated GPUs. The attack surface as well has transformed. The attack surface has moved from vulnerabilities and software vulnerabilities into behaviors, like access to tools, like execution, right? And identity as well doesn't stop at humans anymore. Identity now has to deal with agents talking to other agents. Identity has to deal with model invoking tools, agents gaining additional skills, and creating as well other agents. So the velocity of all those changes are straining like environments that have weak foundations. If you don't have the right foundations, you cannot operate at that speed. But it's as well, some of those attacks that are machine speed attacks are straining human-dependent flows that we have within our tech stack. So security controls here cannot slow this down because the value of AI is velocity. And like I say, if we're not a catalyst to the business will definitely go around security, which is the biggest risk we have. So I like to show that diagram because we deal as well on top of like the stack changing, we're dealing with an unprecedented rate of innovation. So if I show that slide, maybe like 5 or 7 years ago, you would see that same chaos happening in infrastructure. The rate of innovation and would be like through the roof. And as you see now with like 10 years after the cloud era transformation, this is more under control. We'll be a container, we'll be orchestration. We overcame that velocity. We are at the stage of AI agentic AI, we are at that same stage right now. To understand where we are now, it helps to look at the different capabilities that have been happening since the generative AI. So AI has been going through different phases, like the perceptive AI, generative AI, and AI reasoning and coding agents. So the first major inflection point was enterprise LLM adoption. So this was the ChatGPT moment, if you want, when you transition from the research where LLM adoptions was very big, and then you transition to enterprise use. So you start prompting the generative AI, and you start getting those answers. So you, as a security professional, you start worrying about like model leakage, data leakage, model like misbehaving, prompt injection. Those are like the areas you start worrying about. The second point of inflection is around AI reasoning. Now you have not only like a prompt, but you have data, internal data, enterprise data, document that you feed to that prompt, and therefore you start getting like better response. Because the goal with AI is really the best context you provide, the best output you get. So when you start giving like better data and better context, you get a better outcome. And then last but not least, you have autonomous coding agents. So those autonomous coding agents now, they not only they reason, they start executing tasks, they write codes, they push code to production, they start like developing like behaviors in the environment and unbounded. This is really the differences that we see between the three inflection points. Every time security had to adapt, we learn things. So now, those are like accelerating factors. But on top of that, I often say when it rains, it pours. Not only we have accelerating factors with the change of the stack, the rate of innovation, and the other like scale of like adoptions, we have to deal with like AI-fueled like adversaries. And AI doesn't really like optimize the attacks; it reshapes them. It reshapes them because attacks can provide like continuously adapt in real time. They can like scan the environment continuously. They don't take a break, right? And the threat actor as well, they don't need teams anymore. They don't need like expertise to generate like those type of attack. And that results in like three main changes. A change in pace, because now the attack windows is collapsing. We went from weeks to minutes in terms of breakout time. We see as well a change in impact. You start having like human-dependent defenses or perimeter defenses that cannot scale to the machine speed attacks. And then, last but not least, the scale, right? Unprecedented volume of attacks that we're seeing because the AI is lowering the barrier for like the complexity and the persistence of those attacks. So pressure is rising year after year, and we start seeing like a change in the threat landscape. And we see three areas where the shift is happening in the threat landscape. So as I mentioned, the attacks surface move upstream. Threat actors don't rely on like weak credentials anymore. They rely on like system exploitation. So they look at like entry points and they go through it. Once the access is gained to those entry points, the movement happens very quickly. We saw like fastest breakout time in less than 30 seconds. In average, it's less than 30 minutes, and we see data exfiltration in about 4 minutes in average. Again, if I showed that slide maybe 10 years ago, or 10 years or 7 years ago, we were talking about weeks or days, right? I even remember one activity when I was at PricewaterhouseCoopers as a young leader in security. We were helping a customer, and the bad guys were in the environment for months before the first data exfiltration happened, because they couldn't find where the data was, and they were pretty slow around that. So I think it's just like the perspective we have to deal with is really changing. And then third, the supply chain as well. The supply chain scales compromise. Now you have one trusted dependency that can become many downstream victims. So, and 30% of the breaches recently have involved like supply chain. So AI really compresses timelines and prevent us from like, or us when I say the human defenses, to keep up with that. So something has to change there. So every major computational transition looks a bit chaotic at first, right? And Jensen Huang, there's something that resonates with me quite heavily, is he always say, always cause the company to go back to the principles. It creates a lot of opportunities. So, and that's how we should approach securing AI. We shouldn't have to reinvent entirely new foundations. We should be able to apply the same primitives, transform them, maybe accelerate some with AI, and those work around each computing area's transformation. And the new stack now we're operating in, we just need to apply those principles. So we take security very seriously at NVIDIA, and security is baked into everything that we do. It's first principles. It's not an afterthought, and it's something that really we try to bake in as much as possible in all our line of products. So when we look at securing AI, we, as I say, it doesn't mean starting over. It doesn't mean you have to redo everything from scratch. And you all know that the power of security often lays in the layers. And at NVIDIA, we looked at AI as a 5-layer cake. And that 5-layer cake is made of those 5 layers here. The bottom one, energy, hardware, chip, and infrastructure, is what we call the slow layers. Those are the layers that are stabilizing a little bit. And in each of those layers, there's security components that are important. When you look at the compute side of things, we have secure boot, hardware root of trust, or as well confidential computing. And same thing on the supply chain. We have attestation on the product that we provide with integrity checks. Then we talk about the infrastructure layer. So again, data, encryption at rest, role-based access control, very easy principles or foundations, as I mentioned. And then on the infrastructure side, we do the container. And we look at as well, more recently with the rise of autonomous agent, we look as well as harnesses, how we harnesses the autonomous agent. And that's the open shell, open source effort that NVIDIA is pushing right now. And then on the networking side, again, encryption in transit, or in different elements on how you aggregate data points. But one thing that was very key here is our platform not only include GPUs, but we have as well data processing units, especially at the network layer, that helps create a secure compute environment at the network layer. And this is where we partner with TrendAI, for example, to create that security infrastructure so we can quickly triage network activities and push those workloads for GPU to process them. This creates really the engine, if you want, and the capability and speed that help deal with machine speed attacks. So that's an example of a control we have here. Then we talk about the 2 remaining layers. Those 2 remaining layers are actually fast layers or innovative layers. And those 2 layers introduce 2 types of challenges. The first challenge that is introduced by those layers is that we have to deal with non-deterministic outcomes. Traditional security or software security is deterministic. You have a patch, you have vulnerability, you patch it, the vulnerability is gone. You can patch model. Models, you're going to have to check their integrity. You're going to have other model check for the quality output of the model itself. Or you're going to have as well to look for vulnerabilities within the model. Is it leaking data? Is it vulnerable to prompt injection? And one thing that is important as well from that perspective is how you stress test the model with adversarial robustness. So we have as well LLM vulnerability tool, if you want, that's called Galak, that help us kind of look at models and see if they can leak data, how robust they are when we do red team exercises. We build skills around it that we give to that model so it can stress test the models. That's something that we have as well at that layer. And then the last model, as I mentioned, and the second challenge that layer is introducing is actually the scalability of human-dependent functions. So when you look at the SOC or the vulnerability management, especially more recently with the release of Mythos or GPT 5.5 Cyber, we start seeing the limit of those human-dependent controls. And this is where we need to accelerate them with AI. So on the SOC side, having AI agents that do fast triage of the security alerts that help the security analyst getting as well early changes to remediate those alerts is going to be very critical in terms of adapting to AI. And when you look at vulnerability management, and I'll talk a bit about it after, is how do you move the enforcement or the discovery of those vulnerabilities as soon as possible within the stack. So we have AI coding agents we try to build security skills for those AI coding agents so they can not only help the developers code and deploy the product, but as well, can they discover the vulnerability fast so they can fix them before they land in the production environment. That's something that is very critical there. And as well, how we deal with identity of the agents is another controls that is part of those layers. So the goal here, as you can see, is not to generate more controls. It's more how do we automate trust through the security stack, through all those layers, so we can enable the business to operate at AI speed. Every major security pillar assumes two things. Humans are the primary actors, and as well, everything happens at human speed. AI breaks both of those assumptions. And if you look at here, again, I try to show that during the transformation of the data center to the cloud to AI, or even what's after AI with AI superintelligence, or if we look further than that, security has been relying on three main elements. The post-execution, which is hey, you land a code or a system and you check for vulnerabilities after the facts, right? And you fix those vulnerabilities, you have a vulnerability management program, or you detect a malicious activity and you patch that environment. That's the post-execution element. The pre-execution one, which is shifting left, how do you define data flow diagrams, architecture requirements, design solution, bake in security as early as possible so your systems or your product, when it lands in production, is as resistant as possible to vulnerabilities. And then the runtime. Runtime, which is real-time defenses. Often, when I started in my career 25 years ago, the only runtime control was antivirus, right? That was the only runtime. But as we go towards AI, we need to rely more on runtime defenses and runtime enforcement. Because most of the control that we have today, they still assume that we will catch things after they run. That doesn't work anymore. Because if security acts after execution, it's already too late, because the pace that we saw, Mythos or GPT 5.5 is discovering the vulnerabilities and exploiting them, we won't be able to scale to that. So switching gear a little bit, talking about agents, autonomous agents, I think autonomous agents, they combine three things that are pretty interesting here. First, they have access to internal data and systems. They can include credentials, they can access source code, they have enterprise context. The second element that they have is they can consume external data. You get web content that is being fed into the agent, API access, user input, anything that is outside the trusted boundaries. And then third, they have privileges and they can execute. They can call tools, they can execute commands, they can trigger workflows, they can do all those things at the same time. And they do that not at one point in time, they do that continuously. They plan, they search, they do that at a scale that is even not very understandable for us. So that is what makes autonomous agents powerful, but it's also what changes the security problem, as I mentioned. And when we look at agentic compromise, one thing that is important to keep in mind is those three elements that autonomous agents have access to. When you have any of those two, they're actually manageable. Internal data with external data, if you don't execute, you can still manage the risk. We talk about the security role, which is helping managing the risk. We have to take risk. It's still acceptable. Or internal data and execution, still pretty contained. And similarly with code execution and external data, because we don't have a sensitive data involved in that. So there's a lot of elements to consider when you have only of those two together, because the risk is manageable. Now, if the three happens at the same time, if the autonomous agents are combined and we have access to those three elements at the same time, that's where the problem happens. And you start seeing any kind of malicious activity in a way. You have an agent that deleted production data, another that behaved in an unintended way, or one that was using approved runtime to access something for the wrong purpose. The important distinction here is that those are not classic intrusions. Those are actually authorized actions producing the wrong outcome. And I think this is why the problem no longer is only about unauthorized access, but it is how do we look at authorized systems and how do we prevent them from going towards like wrong behavior. So I talked about like the change in the computing space, and often it feels like everything is changing. But if you really zoom out, you start seeing that it evolves, but it remains the same, and it still relies on the existing security primitives. When you go from desktop to client server, right, there's introduction of the network and the server application and the client concept. Similarly, from cloud to microservices, you start having container and orchestration. And now, in the AI native space, right, you start having like agent and application, you're having models, and you use runtime as a controlling point for orchestration. So with the new technology arriving, I think it's good to always look out and see, hey, those are the changes that are happening in the stack, but the security primitives remain the same. And those are the security primitives that we have, defining requirements, clear goals, permission, architecture diagram, data flows, right? Those are very important as well. And how do you operationalize that and automate that with making it as infrastructure as code? The other element that I think is changing as well that I want to point out is around validation. We talk about like AI coding agents that are like producing like code and products, and often we let them produce that code, push it to production, and then we test them for vulnerabilities. That's the change that we want to do. We don't want to test them for vulnerabilities after they run. We want to give the skills and the tools to the developers so they can develop the code and deploy it as fixed as possible. So fixing as you deploy it. And that's where we design security coding skills that we embed with the coding agents. And that's a recent like collaboration we did with OpenAI with Daybreak, if you look at it. Observability remains the same. I mean, only an additional element to observability is that you need to look for behaviors now. So we have our regular like signals that we use from the everyday security, but now we need to look at behavior because, as I mentioned, authorized like access is something that is not malicious activity anymore. We want to make sure that we look at malicious behavior. And what changes as well in that perspective is like enforcement. How do we enforce? We switch the enforcement, right, at the runtime element now. So this is a new emphasis for running agents. So I mentioned there was a shift in the threat landscape where we have like three different like changes here. We have the attack surface that move upstream, we have the attack windows that has collapsed, and we have as well the supply chain that scales compromise. So to address that, like I say, you have to build context, because the example I took is like when you look at AI, your output is as strong as the context you give to the AI. So as you use AI as a defense mechanism, defining and having high-quality context is going to be critical. Really capturing the requirements, the architecture, the data flow diagrams. If you don't define your context with a high quality, there is zero chance you're going to scale to the threat landscape. So this is very important, and that's why I was mentioning as well that not only you have to define the context properly, but we have to provide security skills within the CI/CD pipeline, for example, for the developers, or for like the cloud team, so they can deploy immediately and they can fix almost immediately the vulnerabilities as they deploy and develop the product or the workload. On the attack windows collapsing, again, an old primitive, right? Making sure we separate the surfaces, nothing new there, right? How we make sure that our architecture data flow diagram are like explicit, and that we create for those autonomous agents, like the containers or the environment that we define very precisely so they can do what they're supposed to do. And using infrastructure as code as a control there. And last but not least, we know because of the speed we're dealing with, we need to make the safe path the default path. And I think that's really like important when it comes to validation and observability, but as well when we talk about runtime enforcement and open shell. security must be built into the agentic AI infrastructure from the ground up. And this is where OpenShell, which is an open source project, and we work very closely with the security community and many partners to make sure that we can enforce policies and privacy, security policies and privacy policies at the infrastructure level. So autonomous agents are constrained from unintended data access or even behaviors. And just like in the cloud era, there's not one company that can solve that. I think what is very important to understand is because of the scale and the speed of what we're dealing with, we have to work and integrate with industry partners like TrendAI, with the broader ecosystem and community. We work very closely with the open source community as well to establish those global standards on how to deal with safe AI and deploy safe AI. And I said earlier, we used to say security is a race without a finish line, but an AI turned it into a sprint without a speed limit. But the good news is the defenders are building the engine on our own. As we partner, and as you could see through the different way of the stack, there's a lot of solutions that can be used. And therefore, between NVIDIA platform, the strong partnership, and the work we do with the open source community, this is the way we try to give defenders the ability to operate at their machine speed.